We're going to piggyback off of yesterday's lesson, and we're going to do some more work with solving direct variation problems today. So we're going to continue writing equations that fit direct variation models and solve problems. So remember, direct variation is y equals the constant of proportionality times x, and that the constant of proportionality is x divided by y. Actually, that's wrong. Constant of proportionality is actually y divided by x. So we'll fix that up. If I can find my pen. Y, that's a y, divided by x. There we go. All right, here we go. The distance a coiled spring stretches varies directly with the amount of weight hanging on the spring. If a spring stretches 2 centimeters when a 30-gram weight is hung from it, how far will it stretch when a 75-gram weight is hung from the spring? Well, they said it varies directly. So we'll do the constant of proportionality is equal to the weight divided by how much it stretches. So they gave us one example. A 30-gram weight stretches 2 centimeters. So that's 50 grams per centimeter that it stretches. 15, I'm sorry if I said 50. Then we'll write an equation. We'll say that the weight is equal to 15 times the number of centimeters that it'll stretch. For instance, 15 times 2 is 30, like the example they gave us. And then we can use that equation to answer this question. How far will it stretch when a 75-gram weight is hung from the spring? So if the weight is 75, how far will it stretch? We'll just solve this equation by dividing both sides by 15, and we'll get our answer, 5 centimeters. Okay, now direct variation is kind of synonymous. It means the same thing as proportional. So this could definitely be solved with a proportion too, but I want you guys to try writing these equations. These direct variation models is what they're called. W equals 15s. You know, we could solve this with a proportion like 30 over 2 equals 75 over x. And that would work just fine. But I want you guys to try this. But use a proportion to check your answer. The number of words Tom types varies directly. That means it fits a direct proportion model with the amount of time he spends typing. If Tom types 100 words in 2.5 minutes, how many words does he type in 15 minutes? Okay, well, the constant of proportionality, we'll do the number of words divided by the time he spends typing. They gave us one situation here, 100 words in 2.5 minutes. That would be 40 words per minute. So the number of words he types is equal to 40 words per minute. Then we want to know how many he's going to type in 15 minutes, so we'll plug 15 into that equation we just made. 40 times 15 is 600 words. So in 15 minutes, he'll type 600 words. Again, this could be solved with a proportion. We could do something like 100 over 2.5 equals x over 15. And we could solve this using a ratio table. I want you guys to try writing this equation. Okay? Sometimes I might only ask you for the equation. W equals 40t. And last one for today. Let's try this one more time. Hopefully you see the pattern. Traffic was dense for the evening commute. Mitchell traveled 3 miles on the highway in 15 minutes. Predict how much longer it'll take Mitchell to reach his exit 5 miles away. Okay, so let's assume that this is proportional, that he's traveling kind of the same speed, or averaging about the same speed on the highway. Okay, so Mitchell traveled 3 miles on the highway in 15 minutes. So that constant of proportionality, we'll do, I'll do 15 over 3. So I'm going to do the time over the distance. 15 minutes over 3 miles is 5 minutes for every mile. then I can write an equation, something like this, that the time is going to be equal to 5 times the distance. And then I can use that equation to answer this question. How long is it going to take him to go 5 miles to the next exit? We'll go 5 times 5 is 25 minutes. Okay, so we're going to find that constant of proportionality, that in a geometric sequence, what's everything changing by? It's being multiplied by 5 every mile. So, and then we'll write that equation, and then we'll use that equation to answer the question. Hopefully you see I tried to be consistent here with how I showed my work. Constant of proportionality, write an equation, solve equation. Constant of proportionality, write equation, solve an equation. Constant of proportionality, write an equation, solve an equation. Use it over and over. All of these can be solved with proportions too, and you can definitely do that to check your answer. We'll see you tomorrow.